Welcome back, everybody. In this video, we're going to go ahead and continue with factoring and look at a technique called factoring by grouping. And factoring by grouping is particularly helpful when you have a polynomial with 4 terms. And we don't actually have a special name for that. We just call it a polynomial. But it works particularly well there. And then we can also apply it with trinomials, and I'll show you that in another video, but let's do the basics first. And the whole process here is that basically we create groups and we use this idea of that GCF repeatedly throughout the process. So it's easy to see with an example. So let's go ahead and do that. Now, whenever you're factoring, as a side note, you should always check for an overall GCF first. So note. And this is true in any factoring problem. So you're going to start seeing that questions are just going to say factor, and they're not going to give you a guideline on how to factor or which technique you should use. So the first step in all those cases is to just check, is there a GCF overall that I can factor out first? That's an important step, and it also makes the rest of the process easier. So if I look here, I don't see any numbers in common to all of them. This would be a 1, and then I have a 4, 3, and 12. So the only number that divides into everything is just 1. And if I look at my x's, this has x, this does, but this doesn't. So they don't all have an x either. So in this particular example, our GCF here is just 1. So when your GCF is 1, it's not going to matter. We're not going to factor it out or write that 1 in. We're just going to go with the next process. Okay. So for factoring by grouping, what you're going to do is your first step is you're going to group the first 2 terms and the second 2 terms together. So for instance, I'm going to put grouping symbols around the first 2 terms and then also around the second 2 terms. Now, when you do this, you do want to have a plus sign in the middle. If you have a subtraction sign, I'll do an example of that in a minute. We're going to fix it and use adding a negative instead. But you really just want to have that plus sign. It makes things a lot easier. So that's your first step. Your second step is going to be to factor the GCF out of each group. So I know there's no overall GCF besides 1, but a lot of times polynomials have GCFs within groups of them, and you should see that here. So if I look at this first group, so the GCF in this first group, if I look, I don't have any numbers there because it's just a 1, but I do see they both have at least x squared. So I'm going to go ahead and factor that out. When I factor an x squared out, I still have 1x left here. And then I still have a plus 4 left from the other group. I'm going to do the same idea with the next piece and bring that plus down. So that plus sign just goes right down. So the GCF here, if I look, they each have a factor of 3. So I'm going to factor that out. So the 3 goes on the outside, and then I have an x left, and 12 divided by 3 is 4. So I'm using the factoring techniques from the GCF to rewrite those 2 groups. Okay. Your third step here is to factor out the new overall GCF. So if this technique is working, and it works very well for polynomials in 4 terms, but it doesn't work for every polynomial in 4 terms. But if it's working, you're going to see a GCF appear in each term. So the same factor. So notice here, these are the same. This is your new GCF. Okay. If they're not exactly the same, then either maybe you did something wrong or the technique is not working. Sometimes what you could do too is you could try rearranging the values. Sometimes just switching the middle term, the order will help as well. So if you're not getting exactly the same factors, I would go back, make sure you didn't make a mistake, see if you can swap those middle terms to get a different result. And if it's still not working, then it may not factor this way. But most of our examples you're going to see are going to work. So I'm going to take that GCF. So my new GCF is this x plus 4, and I'm going to factor it out. So I have x plus 4, and then from the first group, I have an x squared left. And then from the second group, I have that plus 3 left. Okay, so there's your GCF, and there's the leftover. And actually, it was the same process up here. So there was your GCF, and there's the leftover, and there's your GCF, and there's the leftover. And now you should be done. So what you can always do too is just check your factors and make sure you can't break them down further. I'll tell you x squared plus 3 cannot be broken down. So this is complete, and you have your factorization now. If you want to, again, you can always check. So maybe we'll do that here. Let's get a different color. So you can see the check done out one time here. So I'm going to check by multiplying. So to multiply something more complex like this, you can use what's called the FOIL technique, or what you could do is use just distributive property twice. So I'm going to do x to x squared. So x times x squared is x cubed. And then I'm going to multiply x with the positive 3, which is plus 3x. And then I do the same thing, but with the 4. So 4 times x is 4x squared, and 4 times 3 is just 12. Now I know it's out of order, but if you actually go and check this to the original, all those terms are the same. So you have the x cubed up there, you have the 3x, the 4x squared, and the 12. So it does match the original example. All right, let's try another one. Again, this one has 4 terms. So really the technique you want to try would be this factoring by grouping. And you would still look for an overall GCF first. So if you have something, you're going to take that out first. Here, if I look though, I don't have anything in common to all 4 terms. My GCF is just 1. So I can go ahead and skip that step. And I'm just going to rewrite the problem. Okay, so remember our first step was to create groups. And if you need to take your notes up from the previous page to have those steps, go ahead and do that. But our first step was to create groups. So you're going to put grouping around the first 2 and then grouping around the second 2. And what I told you though is you do like to have a plus sign in the middle. If it's a minus sign, it gets a little bit weird. So you want a plus sign here. So what you're going to do is just keep that negative with the 2. So we're going to change this to adding a negative. And then that way I don't have to worry about having that minus in the middle, which again makes it a little bit weirder. So we're going to keep that as a plus. Now what we did next is we found the GCF of each group. So our GCF here, if I look, they both have an x squared in common. So when I factor that out, the x squared goes on the outside, and then I have an x left here and a 5 left there. Okay, so that's the leftover. That plus sign now can come right down. And here, now notice that both of these do have negatives. So I want to use a negative 2 as my GCF, so I can factor that out. So when I divide out that negative 2, I'm left with just an x. And then here, 10 divided by negative 2 is positive 5. Again, you want to have the same term here. So if you try to factor out a positive 2, you're going to notice that your signs are off. So a way to fix that is to try taking out a negative instead. That's really common. So it's very common in factoring by grouping to be really close to matching, but maybe the signs are a little bit off. And usually if you just switch your GCF to the negative version, it will correct it for you. And then now we notice that this is the same, which is good. That's what we want. So that's going to be our new GCF. So I'm going to write that on the outside, and then I'm going to go ahead and write what I have left over. So here I have an x squared left, and here I have a plus -2 left over. And of course, what you could do is simplify that a little bit. So plus -2 is the same thing as -2, and that would be our final result here. Now, whenever you have squares still left, you do want to see if you can break things down further. I'll tell you right now that this is as broken down as it can go, and this is going to be our final answer here. I'm going to do one more example here and just kind of kick it up a little bit. So we're going to factor 5x cubed minus 10x squared minus 15x plus 30. And again, you have those 4 terms here. So your best shot of factoring this is going to be factoring by grouping. I will say not everything is factorable, or not every process works with every style polynomial. So sometimes you do hit polynomials that are not factorable, or sometimes you'll hit ones that are a little bit harder, that you have to kind of try some different things. Here, I do see a lot of factors of 5 in common, right? I see 5, 10, 15, 30. Those all have a factor of 5. So I actually do have an overall GCF here of that 5. And then if I look at my x's, I don't all have x's everywhere, so it's just the 5. So your first step before you even start factoring by grouping should be to take that GCF out. Here, 10 divided by 5 is 2, 15 divided by 5 is 3, and 30 divided by 5 is 6. Now we're going to work on factoring this part. And what I'm going to do is I'm just going to kind of leave the 5 for now. We're going to bring it back in at the end. And I just want to focus on this here so I'm not kind of confusing myself. And I'm going to use that factoring by grouping. So I'm going to group my first 2 terms and my last 2 terms. And I kind of wrote a little bit squished here. So let's just write it a little bit bigger. Notice here I have that minus in the middle. So instead of doing minus and then 3x plus 6, I want to make that a plus sign and put that negative with the 3. Now I'm going to take the GCF out of each group. So our GCF here, if I look, is x squared. And here my GCF, if I look, looks to be a 3, right? They each have a factor of 3. So I'm going to factor that out. So in my first case, I have x squared. And I have, oh, sorry, I'm missing some. Oh, sorry, guys. Look at this, should be a 3 here. I was like, that doesn't make sense. Sorry, that's a 3 there. I rewrote it when I was writing it down. We all make mistakes. So that's an x squared here. And that's going to leave me with 1x left over and a minus 2. And then here, if I take out a 3, I'm left with a negative x and a plus 2. Well, I'm kind of looking at this and I'm saying, okay, those aren't the same. Something's wrong, right? My process isn't working, but they're really close to being the same. The signs are just backwards. Here, the x is positive, here negative. Here, the 2 is negative, the 2 is positive. And there is a way to fix that. The way you can fix something like that is to try making your GCF negative instead. So if I make this a negative 3, then what happens is negative 3 divided by negative 3 is just positive 1. So this becomes a positive x. And 6 divided by negative 3 is negative 2. So now we actually do see, I'll rewrite this for you. Plus -2 is the same thing as -2. So now we do see that we have those matching terms. So that's a nice little trick. If you're just a little bit off, it could just need a sign change. So now my GCF is this x minus 2 piece. So I'm going to take that out. And then what's left over? I have an x squared from the first group and a plus -3 on the second group, or of course you can just write that as -3. Now you can go ahead and check this by multiplying it back out, and you should see the same result for right here. So that could be a good intermediary check. Don't forget though, we are forgetting something, right? We don't quite actually have the final answer. So we did have this 5, okay? So don't forget to add this in at the end. So we are going to need to put that little 5 on there to finish the problem, right? Because it did have a factor of 5 in it as well. So we can multiply out, maybe check our factoring here, bring that 5 in. Oops, excuse me. We can even multiply out with the 5 as well and check that it matches the original problem. So you can try those checks at home using the multiplication technique that we saw in a couple examples back. And you should see that this is your final answer. So again, don't forget that 5 that we ended up factoring out at the beginning here.